This is Twit.
Bandwidth for Know-How is brought to you by CacheFly.
Today on Know-How,
Arduino 102, Part 2.
welcome to Know-How. It's a Twitch show where we build, bend, break, and upgrade. I am Father Robert Balliser.
I'm Brian Burnett.
And for as many minutes as it takes, we're going to hold you down and pour the knowledge into your head.
That's right, whether you want the knowledge or not.
It doesn't sound right.
No, it doesn't. But that's okay.
That's okay. Because knowledge is power.
Knowledge is power, and we have a special guest TD tonight.
Yes, we do. Normally we have Steve. We have Steve or Jimmy Joe. I can't remember. Normally we have that guy, but today we've got Kara Cole. That's right, folks. You may know her from things like all the shows on Twitch that get canceled.
Yeah, so that's
that was like a year and a half ago. Okay.
The
you
death
watch
sentence.
out. This show's
Hey,
next.
wait, Ryan. Who TD'd the last episode of Coding 101?
Oh, I believe that was Kara.
Oh yeah. Who TD'd the last episode of Before You Buy?
Oh, that was definitely Kara.
Oh
yeah.
wow. Wait.
Huh.
Uh-oh. Okay,
Oh,
let's
man.
not dwell
It's been
on that.
fun while it lasted.
I know. Thank you, Kara. Thank you very much for going black. No, but we are here to present the second part of Arduino 102.
Yeah, that's right, because we had played around with the basic function of what an Arduino is and how to set up a switch with the button, and then using the RTC, the real-time clock.
Little I2C bus action going on.
And then finally integrating a screen into it.
Right, and we showed you how you could use two I2C devices to display time from one I2C device onto a screen, which was another I2C device. So as you can see, as we get more and more advanced with Arduino, we're going to be using more and more of these I2C devices because we're going to run out of pins otherwise.
Right, right. And that's what makes sense with being able to daisy chain these devices. I like that.
Precisely. And we're going to show you a bit more of that. Now, last week, we did do a quick refresher from the Arduino 101 series. As you mentioned, we did the buttons, and we did writing to pins and reading from pins. Then we did a brief primer on I2C. But the screen we used was this, which is nice because it's big, it's bright, uses up a little too much power. It's not, it's not super energy efficient.
It's cheap.
Little expensive, right? But we also promised them that this week we were going to play with OLEDs.
That's right, yeah, which means that it's going to look a little bit sharper, right?
Yeah, now OLED stands for Organic Light Emitting Diode. Now what we need to do is we need to understand the difference between the technologies. So when I do something like an LCD.
Liquid crystal display.
Right, so what this is let's see, I remember this. When I was a kid, you'd break your calculator and you would take it apart and you'd get the little screen, right? And you could peel it away from the substrate and then hold it up to the sun and you could still see the text.
Right.
Well, that's because when it creates a pattern, be it a letter or a number or a picture, there's no light coming off of it. All it's doing is actually blocking light. So you need a backlight to shine through the liquid crystal, and then the light gets blocked or tinged in a particular color, as we do with, say, laptop screens, and that gives the final color that we see.
Right, and you remember when I did that Game Boy project, right?
Oh, yeah,
And I took apart the screen and put a backlight into it. Same thing.
Precisely. OLEDs work differently. So with an LCD, I have the crystal, and then I have something that creates light behind the crystal so that I can get something off of that. I can actually see something off that crystal.
Right.
OLEDs aren't that. There is no backlight because the screen itself is the light. So OLED stands for Organic Light Emitting Diode. What this is if you go to the side shot here, Kara, this tiny little screen it looks like an LCD, but there is no backlight. The screen itself is the light. So when it creates a pattern, it's not just occluding light or tinging light, it's actually emitting the light. That's why it's an Organic Light Emitting Diode.
Right, and so if you've ever heard OLED for like a phone or something, you'll notice on like that phone that the blacks are a lot darker versus an LCD, a normal LCD screen. Precisely,
but you will also notice on OLED phones, they typically don't do as well outdoors. They get washed out a bit easier because you have that Organic Light Emitting Diode that's actually competing with the sunlight. There's no way it's going to win. The sun's so much brighter. But with like a standard LCD, some of that light, the sunlight, actually reflects off the back. And so even outdoors, you can still kind of see it because as it gets brighter, that reflection will get brighter.
Right. So with this, the OLED, it's a lot smaller than the other one.
Yes, because it's a lot more expensive.
I was going to ask, what's the price on it?
So if you look at this is actually the same price. We've got a link for this. The same price as the other screen, but this is 0.96 inches. It's tiny. And this is actually, it's a 3-color OLED. So it's not even super advanced, and it's going to be way more expensive.
Okay, does it drain as much power? Or?
No, that's one of the advantages of it. I actually put this up on a power meter, and this screen, even though it is OLED, was using something like 1/20th the amount of power as the LCD screen.
Okay.
So
if you're going to do a battery-powered project that you needed a little screen for, this would be the way to go.
Yeah, although there is another option, and remember, we showed you this yesterday. Both in code and in the hardware, there is a way to turn the backlight off. And if the backlight is off, it's basically not using any power.
Okay.
It's a tiny bit of power, just enough to run the little backpack on the back.
Okay, smart. Okay. So how are we going to integrate this into our project?
So what we need, as we learned from last week when we played with I2C devices, is there's always 4 pins. There's going to be the ground, there's going to be the voltage, which in this case, this will take either 3.3 or 5 volts. This is one of the adaptable screens. Some of the OLEDs really don't like 5 volts. This one will do it. Then you need a data line and you need a clock line. This one has one more line that you can, it's kind of optional. I always throw it in just because sometimes you get in a weird state where it helps. It's the reset line. And we're going to show you how to wire that up. So if you go to the overhead, we've got our little breadboard here. So I'm going to go ahead and plug this bad mamma jamma in right next to my switches. By the way, I already have my switches wired into the breadboard. And just like before, we've got the little pull-up resistors. And if you remember, the pull-up resistors are so that normally, even if I'm not pressing the button, there's a current going between the ground pin and the pins I'm going to be using to read it. And that's because the pins, they're not really on or off. They can detect high and low current. And if it's off, it's not high or low current, it's no current.
Right, which is not something that the Arduino can detect.
It can't detect. It's not designed to detect. So what this will allow me to do is, when I push the button, it actually shorts. So it's going to go from current through the resistor to current without the resistor, and the Arduino can measure that.
Right.
Okay. It knows the difference between a tiny bit of current and then all the current. All right, so let's go ahead and start wiring this up. I'm going to need power from my board, and what I'm going to do is I'm going to go ahead and steal power from my Arduino, as we've got those 5-volt pins. I'm going to put them right over here. So I need it for my buttons, and I'm also going to need it for my I2C screen. So let's get another set of leads. This gets a little tricky. Just remember this first pin here, that's ground. The second pin here, that is going to be my voltage.
Can't quite see it on the shot.
There we go. There we go. So that pin is ground, that pin is my voltage, and I just...
You're sticking with the black is ground and red is voltage.
Right, right. Yeah, whatever you do, just stick with a convention. So here's, I'm sorry if you're an audio listener, what I've got right now is I'm going from the 5-volt pins, so from ground and 5-volt into my breadboard. These lines at the top, they're the same all the way across. So all of those top pins are now 5-volt, and all the blue pins are now ground. Now, the reason why I'm going into the breadboard is because eventually I'm going to have to pull power over so that the buttons work. But right now, I just need 5 volts to make the screen work.
All right. So we've got power and ground coming from the Arduino.
Power and ground coming from the Arduino. The next thing I need to do is I need to take my SCL and my SDA, my clock and my data lines. Now, on an Arduino Uno and a Nano,
there should be 2.
A4 is going to be my data.
Okay.
A5 is going to be my clock. So that's SDA, that's SCL.
Okay.
All right, so right there, 4 and 5. Now, if you want to, you can actually pull it from the other side right there. Notice how these are actually labeled SCL and SDA.
Yeah.
That's just, it's the same. They just have it on both sides of the board.
Okay.
Okay, so I'm going to say my data pins are always going to be yellow, and my clock pins are going to be white. And again, this is where it helps to have a bunch of jumpers that are color-coded because it's going to get real confusing once we get a lot of these jumpers in here.
I was going to say, you're being very organized at the start of this one.
Yeah, because it gets to be a mess.
As we get along, yeah.
And I'm not sure if you can see on this, but this tells me my first pin on this side of the OLED screen, that's data, and the second pin is clock. So data is yellow, which means
And now we see the back of your head.
data's yellow.
Sorry.
There we go. And clock is right there.
Okay.
Right? Actually, let me make sure I plugged it in right. Yep, I did. I'm going to use one more. There's reset. And reset it's a sort of a shortcut that the library that we're going to be using, it uses the reset pin to sort of just say, go ahead and clear everything out. Yeah.
In case something gets stuck, or
Right. So my reset pin is right, sorry if you're seeing the back of my head again, right there.
Very good.
There we go. And I'm just going to set this aside because we don't have a pin assignment for it just yet, not until we get into the code. Actually, put it right there. Ta-da!
Okay.
All right. So this is going to give us our basic OLED connection. Let's go ahead and take a look at the code. Kara, if you could take a look. All right. So this is going to look very similar to what we saw last time. We're just doing an example of how this thing actually works. The first thing is I'm including the library for wire. And wire is the library you need for any I2C device. So if you have an I2C device in the project, you're going to have wire.
Okay.
And that's included in Arduino, so you don't have to download it.
Right. And if you're following along from the previous episode,
Yep.
you should already have that included.
Precisely. This is new. Adafruit GFX and Adafruit SSD 1306. These two libraries there's different ways to address the screen. I'm using the Adafruit libraries.
Okay.
You could download another library. My examples will be using the Adafruit. And again, if you don't know how to do this, all you have to do is go to Tools, to Sketch, Include Library, Manage Library, and then type in the name of the library that you want to include. So for example, Adafruit, GFX, Fruit, GFX, there you go. And right there is the GFX library. I've already got it installed. I could update it right now if I don't wanted to, but I'm not going to.
No need.
No need. But just get that installed, and once you're installed, then you'll be fine. Now here's my OLED reset. I'm actually not going to use pin 4. I'm going to use pin 12. So I'm going to take this right here and plug it in. So now I've got the reset into pin 12. Go back to my code. My setup is super simple. I'm going to do wire.begin. This is just like serial.begin. All it does is say, hey, turn it on. I know you have the library for it, but let's enable the functionality now. And start it up. And the second line here, this is unique for this screen. Display.begin SSD 1306, so it's calling the library that I just downloaded. And it's going to initialize that device with the address 0.3D.
Right, which we saw in the last project with the LCD, which had a different, kind of address. But
Precisely, and when we get to the end of this episode, it's going to be interesting because we can actually run multiple displays off the same Arduino as long as they have different addresses.
Cool.
I cannot run two devices that are using the same address because then it won't know which one it's talking to.
Right, okay.
Okay, so that's important. Remember that. All right, let's take a look at the loop. My loop is super simple. Remember what a loop does in Arduino. It's just going to, anything that's inside this loop function is just going to keep happening again and again and again. It's going to do it as often as it can until it runs out of power.
Right.
So it's going to start by setting my text size at 1. Then it's going to set the text color as white. Then we saw this in the LCD example. Set cursor 0.0. This, remember how last week it was
I think it was x-axis and then y-axis.
X, Y. This week it's Y, X. Don't ask why, that's just how they built the library. If you want, you can switch it and build your own library.
And what is is it 20 by 20? Is that what
this is a 128 by 64 screen.
Oh, okay.
So it's much higher resolution, but you have to remember the other one was 20 characters by 4 characters.
Yeah.
This is 128 pixels by 64 pixels.
Okay.
So it really is a smaller screen. But I mean, the other
higher
one,
density, yeah.
Higher density. And I can actually make pictures on this versus the LCD screen where it's just text and numbers. That's all I can put.
Okay.
All right. So I'm going to print hello world. Then I'm going to move the cursor to 0.20, which is going to drop it down.
Right.
Then I'm going to print goodbye, Cranky Hippo. Then this is important. Display. This does nothing. This library does nothing until it sees display. It says send that out. Whatever you set up, send it out.
Okay.
It's just like the function that we use with our WS2812s, where you can fill the array, but until you use the show command, it won't push it.
Okay, so that's the show command, and then beneath that is how long it'll be up for, 1,000 milliseconds?
Right. So 1 second, hold it, and then display, clear display, which sends the command to clear the display. But just like last time, it doesn't actually do it until I put display, and then wait a second. So if I coded this right,
it should loop, right?
Right. It should type hello world, goodbye cranky hippo, stay up for a second, then go blank for a second, then do it again for a second.
Right.
So let's go ahead and upload this. So I'm going to the right board. Let's see if I made any mistakes. Yay, and compiling my sketch. It's going to take a while because this is the first time it's doing it. And uploading, and done uploading. All right.
Cool.
So
no errors.
if you go to the side or top cam, I'm not sure which one shows it best. There you go. So it's just saying, hello world, goodbye cranky hippo.
Blinking on and off.
Blink. Super, super simple. That is just a static display.
Yeah.
But I could put anything there. The reason why we're giving you a simple example is so that you can take my example and fill it with anything you want.
Yeah, and that looks pretty sharp. That's that's pretty easy to read. I like that.
Now you will notice there is a slight flicker, and you have to be careful with that. See, you can see it, right?
I see it.
Just look at the screen. No, don't look at the TV, not at the screen.
Oh, why is that?
It's a tiny bit. It's just the refresh rate. It's the if there is actually two different ways to connect this OLED screen. The first is the way that we've done it with the I²C, which is super, super simple.
Right.
But it's not the fastest refresh rate.
Okay.
There's another way where you could use all of the pins up top, but it's going to take a lot more wiring. It's much more flexible. I can do much more with the screen.
Right.
But for the purpose of our project, since we just want to use it for display, not really for graphics, I²C works just fine.
Okay, but so for like our last project, we had to address individual digits so that they refreshed and not the whole thing. Do you have to do that for this too? Okay.
Yeah, anytime you're dealing with I²C, just remember that the refresh rate isn't as high as, it's not like I'm plugging a monitor into my HDMI port. So anytime you can reduce the amount of stuff that has to refresh, the better it's going to be.
Okay, cool.
Okay. And actually, if you want, let me do this. Let me show you what happens if I put a delay of, let's say, 10 milliseconds. So even here, I'm still being kind because I'm adding a delay. But if I didn't do that, so let's say I was changing my text, it would do something like this. So yeah, that's no bueno. No, in fact, don't. Cause
that makes it look broken.
If we have anyone who's epileptic, don't show that. There we go. Okay, so that's why you got to be careful about how you manage the data that's going on the screen.
Okay.
All right. So that's the super simple one. Let's get a bit more advanced. You ready? I mean, this makes sense, right? The setup is super simple.
Yeah, that makes sense.
Power, data, clock. Done.
All right.
Okay. And actually, look. Actually, let me change it so that it's not
flickering like that.
Yeah. I told you that reset pin wasn't really necessary. It really isn't. 99% of the time you can run without it.
Yeah.
There we go. And
does it do a little boot up screen too?
Yeah, the library does. So I can remove that reset. Actually, let's do it up here. I can remove that reset pin, and it still continues to work just fine.
Okay, so it just sends, if you were to integrate the reset pin, you would just type into the code to send the signal over that, like a data pin almost? Or?
Well, it just means that every once in a while it might get stuck in a weird state that it can't recover from, but that is so rare. I think that's happened once in all the time I've been playing with it.
Okay.
All right, so let's do something a bit more advanced, shall we?
Sure.
Okay, now last time, you remember we had the RTC.
Right.
Now the RTC allowed us to keep time, real time. So even if we powered down our Arduino, we still have the ability to know what time it is in the real world.
Right, because it had the little battery on the back. But then we also had to make sure when we uploaded our code, we had to upload it a second time with the set date and time and everything commented out.
And that's because when you first get these RTC modules, most of the time, well, two things. One, they almost never have a real date set on them. Two, most of the cheap ones, and I always buy the cheap ones, have really bad CR2032 batteries in it. In fact,
so they might even be dead by the time you get them.
Precisely. Yeah. So if it keeps dying, there's nothing wrong with the module. It just means they put a really cheap lithium-ion battery in it. Just replace that and you'll be good.
Yeah, those are pretty standard.
Yeah. All right. So this is also an I²C device. So I need to hook it up to the same bus. We got a little messy last week in where we hooked it up. This week it's going to be much more clear that we are using the exact same pins. So the first thing I need is I need power. And on this one, my power is black is for ground and white is for voltage. So I'm just going to go ahead and plug this in like so. So now I've got power to my device. And on this, let's see, my SDA is gray and my clock is purple.
Okay.
So remember, yellow here was my clock and white is my, oh no, yellow is my data and white is my clock. So I should be able to do this. Same lines,
Right.
Just plug it straight in and straight in. So these two devices are literally connected, because remember, anything that's vertical like that, it's the same line.
Right.
They are connected to the same wire.
Right. If we weren't using the breadboard, we could have the same wire soldered together for
Yeah,
both
we could.
devices. Yeah.
That'd be super massive. But
Right,
I mean, you
but yeah.
can. It is the exact same electrical connection. Okay, now we have to do something interesting with it. And if you go back to my code, we have that more interesting thing right here. Oh, no, that's the last example. We want to go to example 2. All right. What we've done is we've included a few more things. So we still have wire. We still have the Adafruit library. But we've added this. You saw this last week. This is defining the DS3231. This is the I2C address for my clock, for my real-time clock.
Right.
And it's different than my screen, because remember my screen was 3D, 0 by 3D, and my clock is 0 by 6/8.
6/8.
Different addresses, they won't conflict. It doesn't matter.
Is there a limit to how many devices you can have?
Yes, and it really is a hard limit based on the type of devices you install and how much wire you have.
Okay.
You kind of want to keep the wire short.
Right, because you're having to push that voltage through that distance.
Well, it's not so much the voltage, it's just the data becomes incomprehensible when you're pushing over 15 meters of wire.
Yeah, okay.
Yeah, just know that. All right, so let's go back to my screen. I'm doing the same thing, OLED reset. We're going to set that for pin 12. I'm initializing my display. All of this, the byte, the decimal to binary, the binary to decimal, that's the stuff from the real-time clock library. I'm not going to go over it again because we went over it last week. But my setup is super simple. Start the serial console, although I actually don't need it right here. Start the I2C bus and start my display.
Okay.
Simple, right?
Pretty straightforward.
Okay, and then I've got my standard, I can set my time for my real-time clock. Here is the one that allows me to read my real-time clock. This is the one that allows me to display the real-time clock on the serial console, although we're not going to do that in this episode, so I can actually delete that. And then here's my loop. Remember, this is the program. This is the actual thing that's going to repeat over and over again.
Right.
It's going to display time on the serial monitor. Then it's going to, actually, I'm not doing that, so I'm going to comment that out. It's going to create the variables to store the data from the real-time clock. Then it's going to read the real-time clock. And then this is what we just did. So I'm setting my text size, I'm setting my color, I'm setting the cursor to 0.0. Then I'm printing hour, printing a colon, printing minute, printing a colon, printing second, printing a colon, and then, or not a colon, then display.display.
Yep, display.display, and then you have the delay at the bottom, and then a clear display after that.
Which
Okay.
just, because here's the fun part. If you don't overwrite a pixel that was previously used, and you haven't cleared the screen, it actually stays there.
Okay, that makes sense though.
Yeah. Which is a problem.
Well, then you just can't read it, right?
Well, it just means eventually all the pixel space will be used. Oh, I didn't send a COM port. All the pixels will be used. It'll just be a solid white screen.
Right.
That's not really usable.
No,
That's
no.
not super useful. Okay, it's uploading and.
And you said this
Done.
OLED has 3 different colors you can do?
Yeah, I think this one I set for white, yellow, and black.
I mean, white makes sense because that would probably be the easiest to read at the moment.
Wait,
but
which way? Which
you
is
had
that?
it right the first time.
I did? Okay, hold on. I'm making my onions dizzy right now. And there we go. So it's super simple. This is just a clock. So all it's doing is it's displaying, it's 18, so that's 6 hours, 8 minutes, and 51 seconds.
Yeah.
Yeah. Now, if I wanted to get better than this, we could use the same math, the same setup that we used last week. Remember, we did a series of if statements so that this would look right. Because the reason why this doesn't look right is normally we see 18, 09, 11.
Right.
So what I would do is I would put an if statement there that says, if it's less than 10,
Put it as 0.
add 0 first, then write the number.
That makes sense.
Same thing. I would do the same thing for the hour and for the second. Right now, if it was midnight, all it would show is the seconds. It would show 2 colons and the seconds, because the others would be empty. There'd be no values there.
That makes sense, yeah.
So I mean, yeah.
Those are little things you run into. Yeah.
Precisely. This is the super simple setup, but again, I'm using the same I2C bus, which is what I want people to realize. I can use this again and again and again. I'm not running out, I'm not using any more pins.
Right, now what I want to see you do is hook up the LCD in there also.
Maybe we will do that, Brian.
Yeah?
Maybe we'll do that right next, coming up.
Oh, okay.
It could be. What do you think?
I want more screens on screens.
Screens on screens on screens?
I mean, this is the super simple, just we're showing a clock.
Yeah.
I could look at my phone.
Hey, no, but this is wires.
Right. No, it's cool.
Better.
I like the concept.
Yeah. Now, here's the thing, though. Even though the RTC, because it has its own battery, it will maintain its memory, the Arduino will not.
Right.
We're going to talk a little bit about memory usage.
Okay, but so like with the code that we have right now, if we were to restart this, do you need to re-upload it with the set time commented out?
Because there's actually different types of memory, and that's exactly what we're going to explain. The different types of memory and how to use them. Most of us are only using 2 of the types of memory that are in an Arduino. There's a third that's specifically for us when we don't want to lose parameters, variables, when we power off.
Okay, we're going to learn about that?
We're going to learn about that.
But first, something else?
But first, I think these messages.
Here's just a few of the stories that we'll be looking at in the week ahead. Samsung will hold an event to unveil their latest flagship phone, the Galaxy S8. The company is hoping for the latest Galaxy to make a big splash to finally put the Note 7 debacle behind them. RIP Club Penguin, one of the first social networks for kids, is finally shutting down on the desktop and mobile devices on March 29th. It started nearly 12 years ago in 2005. Brian McClendon, Vice President of Maps and Business Platform at Uber, also plans to leave the company this week. Probably someone else will leave Uber this week too, if I had to bet on it. Bluetooth World in Santa Clara, Black Hat in Asia, and April Fool's Day are all happening this week. Plus, March 31st is World Backup Day, so back up your stuff, my friends. That's just a few of the stories we'll be following this week on Tech News Today, every weekday at 4 p.m. Pacific and 7 p.m. Eastern on twit.tv.
Brian, there are 3 types of memory in an Arduino.
Okay.
Okay, so there's the flash memory, and flash memory is where we store the program. So when I upload a sketch to my Arduino, it's going to store it in the flash, and flash is non-volatile, which means it will be saved, right? Until I overwrite it, that program stays inside the flash memory.
Okay, but all right, so if it loses power, it'll be saved.
It's safe, right? That's why I don't need to re-upload the code to an Arduino every time I turn it off. That part is safe. Then there's the SRAM, which is static random access memory. That is volatile. So if I unplug the power, the flash is safe, but that SRAM gets wiped out.
And what is usually saved in the SRAM?
That's the memory. That's the computer's memory. That's the system memory.
Okay.
Right? So the idea is any of my variables, anything that changes, that's stored in SRAM.
All right.
Okay. And that's, it's useful because it's fast. We want our system memory to be fast, but because it's volatile, it does mean that if I'm not refreshing the cells every so often, they just deteriorate into nothing.
Okay.
Which is why that goes away.
Right, when it loses power, okay.
Those are the 2 types of memory that most of us play with. We play with flash because that's where we have to upload our programs to, and we play with the SRAM because anytime a program is running, it's using the memory, the SRAM, the system memory, correct?
So is that in any way similar to like a PC? With
absolutely.
Like your hard drive would be like, there's flash memory, there's SSDs for our PC, but then also RAM.
Yeah, and it's exactly the same thing. So, and actually now computers are even closer to this because most of us are using flash devices.
Right.
So our flash storage is non-volatile. It will stay there for a really, really long time. It will take a long time for that charge to degrade to the point where it cannot be read anymore.
Okay.
Then we have our system memory, the 32 gigabytes of memory that you have. And the more that you have, the more your computer can do simultaneously.
Right.
Right? And then we have the third type. The third type is EEPROM.
EEPROM.
EEPROM, which stands for Electronically Erasable Programmable Read-Only Memory.
So does that stay if it loses power?
Yes.
Okay.
But we'll talk about it. Back in my day, we used to have lots of ROMs, read-only memory. Those were burned at the factory. They could not be erased. They would always have the microcode that they had on them. No matter what happened, they would always have the same instructions. Then, right about the time that I was in grade school, we started being able to afford, and by afford I mean I was able to dumpster dive for the equipment that let us use EEPROMs, erasable programmable read-only memory. And what you would do is you would expose it to intense ultraviolet light, and when it got hit by intense ultraviolet light, it wiped the memory. There was actually a little window in the top of the chip. You've seen those.
I think I've seen those, and they were on, it was like game cartridges and stuff like that, like early Nintendo cartridges.
Yeah, well, because the thing with a ROM is you can't update it. So if you update the wrong code to a ROM, you throw it away. It's done. With EEPROM, as long as you had that UV light source, you could wipe the memory and start over. Now, I mean, you didn't want to do it constantly because it was a slow process, and eventually it would no longer be erasable. But I mean, it was a nice way. It was a way to store and refresh your microcode.
And we're probably talking about really small amounts of memory.
It was not huge. Yeah, a couple of K. At most.
Yeah, not even megabytes.
And then we created what was called EEPROM. And it's the same idea as the erasable programmable read-only memory, except I don't need a UV light. Now I can do it electrically. So if I run charge in a specific way through that chip, it will erase the contents and allow me to overwrite them.
That is much more convenient.
That is super, super
than trying to shine a UV light on something like that.
Which is why you don't see ROMs and you don't see EEPROMs anymore, because they're just obsolete. The only time you will see those is if you have code that you really don't want people to screw with. Like I will still use ROMs every once in a while, where I can write it once and that's it. It'll never be rewritten again. But if I'm doing that, it's because I never want it to change.
And you're sure that the first time you do it, you got it right. Yeah.
Okay. Now, let's take a look at this. So what we have are 3 different types of memory on any Arduino that's based on the Atmega. This is the 328. It's got 32K of flash, so I can store 32 kilobytes, bytes, not bits, kilobytes worth of program. I've got 2K of memory, system memory, and I've got 1K, so that's 1,024 bytes of EEPROM.
Okay, coming from like a PC background though, that sounds super tiny.
It's like the first computer I ever owned. Actually, it's probably less than the first computer I ever. No, I had a Timex Sinclair that had 8K of memory total.
But that's probably more than enough for the programming that you need to do for a lot of this stuff,
Precisely, because we're not running Windows. These are really slimmed down programs. You've seen the code for them, and most of the time we're using like maybe 30–40% of the memory that's on there.
Yeah.
But that EEPROM, what it will allow us to do is to write to storage on the Arduino that will not disappear when I remove power.
Okay, cool.
And we're going to show you why you might want
to do that. All right, let's get into it.
So the first thing we need to do is I need to be able to store some kind of value. So I'm going to go ahead and I need to wire up 2 switches here. I've already got a little lead that with 4 wires that I'm going to go ahead and plug in here. So I'm going to go from switch port number 2. So that's 0, 1, 2 through 5. 2 through 6. No, wait. 2 through 5. There we go. 2 through 5. My first pin is going to be black, so I'm going to plug that in right here.
Ground.
And then I've got that. Then I've got this. Then I've got that. Now I need to pull 5 volts to each one of those switches, so I'm going to pull from my 5-volt lead down into the switch. Can you make sure I'm plugging that in right?
Yeah, sure.
It has to be on the same rail as the actual pin for the switch.
Yeah, you're good.
Okay, and actually you probably have a better view, won't you?
You want me to plug in the rest of them?
You do that one.
Cool.
And you do this one too,
Yeah, so
Brian?
we're just taking power from the Arduino off of that breadboard rail.
Right.
And we're just making little circuits for the buttons.
Little circuits for the buttons here. You do that one, and I'll do this one.
Okay. Here, I'll let you go first.
There we go.
Teamwork, Padre.
Teamwork. And remember, the reason why we're doing it this way with that pull-up resistor is if in normal operation, so when the switch is not open, there is a very, very slight current that's flowing through that 10K resistor.
Right.
When I push the button, it actually shorts it. It goes directly from the ground rail into my, my digital pin.
Right.
So that means that it's going to be full current. So I have low current normally and then high current when I push the button.
Off or on?
Off or on. That's what we're using to set off or on.
Cool.
All right, so let's go ahead and go to my example here on my screen. This is the counter example. And again, folks, you don't have to copy this off the screen. We make this available for you. There's a little link so you can just download it.
No, I refuse to put this code on the show notes. You're going to have to look at the screen and copy it all right now.
How sad. All
No
right, so
pausing either.
what we've done is we're just going to do really quickly. This is an example. It's called the counter. So I'm using just 1 pin. I hooked up all 4, but I'm going to use 1 pin right now, 1 switch. All it's going to do is when I upload this program, it's going to set the pin mode for that first pin to input. So it's going to listen. Then it's going to turn on my I2C bus, then it's going to initialize my display. And what my display will show is the counter from that button. Every time I press that counter, see counter equals counter plus 1, every time I press that counter increments by 1.
Okay.
Okay. Now, what it will do is it will display that counter. So it's the same thing. It's going to clear the display, so it's going to empty it out.
And then push that out.
Display,
yeah.
push it out. Then it's going to set the text for 4. It's going to set the text color for white. It's going to set my cursor for 33. So it's going to be somewhere closer to the middle of the screen.
Oh, okay.
Then it's going to display, it's going to print the value of counter, and then it's going to display. All right, so let's go ahead and push this. Make sure it's going to COM3. Yep, there we go. So compiling.
And so now you're compiling this, and this is going to the flash memory.
Right, so right now I am writing to the flash memory. I'm not writing to the EEPROM. You're going to see the command for that. I just want to show you how this program actually works.
Totally.
All right, there we go. So if you come back here, that's all it does. So as I press, and see how it's looping over?
Yeah.
So if I hold it, it just keeps rising, keeps rising, keeps rising. Let it go. Actually, let's see.
What will it go to?
This will actually go to, I think this is 16-bit, so this will go to 65,536.
Okay, all right.
Or actually 535, because it also does 0.
Prove it.
If you want me to prove it, we're going to be here an awful long time.
We've got time.
Actually, I could go in the code and say count by thousands. That's kind of cheating. But here's the problem. If I pull power and reattach it, okay, so it's going to do this little boot screen. I'm going to get a little welcome screen. So if I reapply power, and do a quick boot, you'll notice when I start the counter again, it's going to start from 0.
Ah, okay. That's cool.
Well, I mean, yes, but the problem is that I'm losing my values.
Oh, yeah, but it still works.
What if that counter was important? Like, for example, let's go to my Arduino example. What if that was counting how long it does the watering, and then it loses power in the middle of its watering cycle, and it thinks it's starting all over.
Right, and then you come back to a flooded bedroom.
Come back to a flooded bedroom. Or, even worse, what if I'm using this to count on how much nutrients to add to the water, and it keeps having a bug where it keeps browning out, and it just keeps resetting to 0 before it gets to the stop.
You speak like a man who's gone through that before.
This is not hypothetical. This actually did happen. What we need is a way to make sure that that value, whatever that counter is persistent. It stays after power off.
Okay. And that's what we got to use the EEPROM for,
And that's what we're going to use the EEPROM. So if you go back to my screen, Carol, we have a wonderful little example here for the EEPROM. It's the same program. I've now added the other 3 buttons because I need them to do things. What I'm going to do is I'm going to have button 1 increase the count, button 2 is going to decrease the count, button 3 is going to save the count, and button 4 is going to reload the count.
I like that.
Right,
okay.
so let's show you how it does it. These are the holding spots for my button variables.
Right.
Okay, and then everything down here is, you've seen this before, I'm starting my I2C, I'm starting up the display, I am telling all of those pins that this thing is going to be connected to that they all need to listen, they're all input, and then my loop is actually pretty simple. Check button 1, button 2, button 3, and button 4. So I'm doing digital reads on all 4 of the pins. What that means is I'm checking to see if any of them are pressed. Have any of them moved from low to high? If any of them have, then it does this. It's the conditional statement. So if button 1 is high, then add 1 to the counter. And then this part we've already seen. This is just displaying that to the screen.
Right.
If I hit button 2, counter equals counter minus 1, and then display that to the screen.
Cool.
Here's the difference. If I hit button 3, first of all, you'll notice I have a while statement here. This is actually kind of important. Notice how when I hit those the first button, it actually counts up really, really fast, right?
Right.
If I have the write function, so writing to my EEPROM function, set up the same way that I set up the counter, it's going to write hundreds, thousands of times if I just hold that button down.
And that probably it can't do that, right?
It wears it out. I get 100,000 writes per cell. So it sounds like a lot, but if you mess up and have it in the regular loop, I mean, an Arduino can go through thousands of loops in a minute. And you could just kill all of the life of the cell. So I want to make sure that when I push that button, it only writes once. And that's what this is going to do. This is very short piece of code, but you're going to see me use this a lot. If button 3 is high. So if I push button 3, it's going to trigger this function, this part of the function. Then it's going to say, okay, while you're still holding that button, do nothing but stay inside the loop. And all it's going to do is keep checking that button. It's going to, and once I release it, so once it goes low, then it moves on.
Okay.
So if I press and hold that button, it's just going to stay at the start of that function until I release it.
Instead of continually writing.
Instead of continually writing, which would mess up my EEPROM. Okay. So that's it's not the only place I'm going to use it. You're going to see me use it anytime like a menu moves too quickly. And I want to make sure that one button press means just one button press.
Okay.
All right,
makes
so
sense.
go back to my, my screen, Kara, and you're going to see here, this is my function. EEPROM put.
Dot put. Okay.
Yeah, and you can look up in Arduino their database. You can look up all the EEPROM functions. Put's really simple. Put the value of counter. So and this I could hard code this. I could actually have it be a number. But I'm saying put whatever the value is of counter. That's the variable I'm using to count up and down.
Right.
And then put it into cell number 100. That's it.
And why 100?
I just chose 100. I could choose anything from 0 to 1023.
Okay.
Because I've got 1K of memory. So it's 1 byte memory cells.
Okay.
So 8 bits to 256 possible values.
Okay.
Okay, so just know that. It's 256. If I want to store a value that's higher than 256, I have to do some creative math to cut it up into multiple cells.
All right, but we don't need that.
We don't need to do that.
Keep it simple. Yeah.
Unless I do the Kara thing and we count up to infinity and try to store it.
We might save
We're
that.
not going to do that. All right, so if I upload this, let's go ahead and tools, COM port 3, and upload. There we go, compiling. What it should do is it should allow me to increase or decrease the count using those first 2 buttons. I can save the count using the 3rd button. Then I should be able to pull the power, plug it back in, and then restore the count.
All right.
All right,
Well, that's the hope.
All right, so here, if you go to my screen, Kara. All right, so actually, look, I can go down to negatives now.
Whoa.
So I can increase and decrease. So let's say I want the value of 16.
Okay.
So if I press this 3rd button, saved. Okay.
Did you write in the function to show save?
Yes, I did.
Okay.
Yeah,
I
that's all.
didn't
That's all in
notice
there.
that.
But now look. So if I increase or decrease, but then I go back and I hit the 4th button, which restores.
Restored.
It's going to go back to 16.
Okay.
And so if I pull power.
Hold on. What if I change it to 22? Now pull power.
Okay. Okay. Oh, I got it. So you want it to be a different
A
value.
different number because it's supposed to come back to 16.
Right. So I'm going to pull the power. I'm going to reconnect it. It's going to do its little boot up dance because it's a boot up dance. That's what it is. Okay, there we go. So now I have to hit restore and boom.
16.
Back to 16.
All right.
So
nice.
this is where I want to store any persistent information. So for example, in our Arduino, I'm going to be doing input where I set a grow time. Well, or like a watering
time, yeah.
Or a lighting time, whatever it might be.
Fertilizing time.
Fertilizing time. I don't want to have to re-input that every single time the thing loses power.
Right.
It'd be like your VCR flashing 12 all the time. I mean, it works fine as long as you don't lose power. Right. Well, you could buy a UPS and keep the thing battery powered at all times, or you could write it into your program so that every once in a while, when it needs to, it saves it to memory. And then when it boots, it recalls it from memory. Right. In fact, it would be really simple to do that. Kara, if you go back to my computer, what I could do, and actually this is what I do with the Arduino. So the counter equals EEPROM read 100. So what it's doing is it's putting whatever is in the cell 100 in the EEPROM into the variable called counter. I could actually put that into my setup. I could put that right here, because remember, setup runs once when the Arduino boots. What this would do is every time I lose power, it would go ahead and fill that variable back with the last thing that was saved inside that cell.
Oh, that's pretty clever.
And actually, yeah, so let's do that right now. So I'm going to go ahead and upload this. So now when I save a value and I pull power, when I reapply power, it should go back to that same saved value.
I like that idea.
So let's.
Because the real fear is if you did this as a hydroponic setup, if you lost power and then it reset and then it started from the beginning.
Yeah, not good, not good. All right, so if you go back to my example here, so there we go. So let's store. Okay, you run it, so you know how to do it now. So go ahead and store the value of 30.
Saved.
Saved. Okay, and now we're going to pull it.
Go ahead.
Put it back in. It's going to do this little dance. Loop. There we go. And actually, it's not going to show you because I didn't code that properly. But like, let's go ahead and decrease a little bit. It's going to decrease from 30.
Yeah.
So,
yeah. Instead of from 0 or whatever.
So I can set it up. And remember, EEPROMs only get worn down by writes. They don't get worn down by reads. So I can read it as many times as I want.
Okay.
Now,
nice.
Here's the warning I'm going to give to people out there. Do not treat this like system memory. It is not a place for you just to jump any value into because you think you might need it later. Because remember, you are really limited to 100,000 bytes. It sounds like a lot, but it really isn't for something that's going to be running all the time.
Okay. So, all right. I guess then keep that in mind. But then can you store those values that you need, I guess, just in the flash memory then?
You can. Yeah.
But you're going to lose them.
Well, yeah, precisely. So, for example, okay, if you go back to my screen, up at the top, I have those right here. So these, all of the variables I declare, that's all going to be in the system memory.
Right.
Okay. I can't write to that flash memory because that flash memory is what my program is.
Ah,
that would be bad.
Right.
We would not want that. That would cause really bad things. Also, there are different amounts of memory. So this is really where you start looking at what type of Arduino do you get. So the Uno or the Nano, which are the ones that we've been using almost exclusively, they have 32K of flash, they have 2K of SRAM, and 1K of EEPROM. But like the Mega, which is the next one up, that has 64K of flash, it has 8K of system memory, and then I think it has 8K of EEPROM.
So substantially more.
Substantially more, right. It's a bigger device.
So would you recommend that for a Groduino project?
No,
because you don't need that much.
I'm almost done with the coding for my Groduino, and I'm not getting anywhere near it. I'm using not 1K, I'm using 8 bytes.
Oh, okay. So you're good.
I'm good. I'm good. All right.
Very cool.
All right. So that's EEPROM. This is important because this is the first time that we've given them an easy way to do persistent memory. There is another thing, like for example, there are I2C devices that will take SD cards, and now you have a ton of memory that you can write to.
Okay.
All right. And we'll be playing with those. But now that we have I2C, it's going to be a lot easier to add these. In fact, if you look at my little toolkit right here, so this is the thing I carry around with me anytime I want to be makery. So of course we've got our WS2812 rings, but all of these, like these devices, these are all I2C. Oh. So I can daisy chain them. In fact, this is the thing that allows me to daisy chain it. It's like a little hub. So I can plug in from one to the other. This one's a sound sensor. This is a real-time clock for I2C. These are knobs. These are encoders that are all I2C. This, actually, I do have a project with this. This is a touch sensor. So if it touches, it can actually set the high and low condition.
Oh,
and I can address all of those over the same 2 wires. So we're going to be adding to our I2C repertoire as we go more and more in depth.
Very nice.
But Brian, at the beginning of the show, you wanted to see some screen-on-screen action.
I want to see the LCD screen hooked into with the OLED.
Yes, that's greedy, that is.
Why? It should be easy, right? Can we display the same function on both screens, like the same program?
Well, what did I tell you? What's the one time that you cannot combine 2 I2C devices?
When they have the same address.
Right, and they don't.
So we should be good then.
We should be good. We do have to make sure that there's enough power because we're still running everything off the Arduino.
Right.
But that's not a problem. We're going to get back to that in just a second. But you know what, Brian?
What?
The first thing we have to do is listen to these messages.
Previously on Twit.
If you can't afford a red phone, you can at least get the new product red case.
I don't use cases.
No,
I don't use cases at all. I stick it in here and it disappears.
All about Android.
Like Christmas coming early, Google released the Android O developer preview. The developer preview version hit, and it is now available for download and install, and everyone has been scrambling to check it out.
Tech News Today.
Nate was talking about a game called Everything, where you can play as anything, a blade of grass.
Everything is a strange experience in which you don't really have an ending, and then you just start to really ask yourself, what am I? Who am I? Where are you? What is Twit? You know, it's just a lot of important questions.
This is your brain. This is your brain on Twit. Any questions?
I mean, I'm beautiful the way I am. There's no need to put me in a case.
No need to put Jim in a case, that's for sure.
So let's get ready for some screen-on-screen action.
All right.
All right, so I2C, because it is a shared bus, it should allow me to run multiple screens as long as they're not using the same address.
And your wires aren't too long. And we have enough power.
And we have enough power.
Okay.
Yeah. And I've tested this before, so all those things are good.
Sure. Yeah. Well, this is a live demo, so.
This is a live demo, so it probably will die. But here we have our wonderful little 2004. This is our LCD 2004. Again, it's got an I2C backpack on the back, so all I need is I need ground, I need power, voltage, I need data, and I need clock. So let's go ahead and hook this thing up. Right. My data is going to be the white wire, and black and red as normal are going to be
ground and power.
Ground and power. So let's go ahead and get some ground and power on this thing. If I can see this right way. These pins, by the way, are getting so bent and loose.
It's because you've been doing so many projects.
I have been hacking so hard, Brian. Okay, so data is this white one, and the clock is the brown one. And I know over here, data is my yellow. Can you, here, plug that in the yellow.
So white will be in line with the yellow.
And brown.
Whoop. And brown is going in line with the purple and I guess another white.
Yeah, there we go. Okay, so now I've got this, but of course, there's no code here yet that's addressing this screen.
But we are getting power.
This screen. But we are getting power, so this is good. And nothing has smoked yet.
Nope.
And our little example is still working.
Yay. Yay. Although, you know, there's plastic on this screen and it's
I am Filipino, you leave that plastic on.
It's really bugging me.
Okay, look, once you remove the plastic, it's not new anymore.
How long are you going to leave that on there?
Until it gets dirty, and then it's like you get a brand new screen. See, I never understood that about you people, okay?
You people,
you don't understand. They've given you basically a protector, and you want to peel off the screen protector?
Yes, because I want to enjoy the thing that I just bought.
You know what? You need to come over to my house more often.
Yeah, your plastic couch.
My dog is actually covered in plastic now. That's weird.
That doesn't sound healthy.
That's probably not. All right, so if you go to my code, so what we've done is we've added back this library. If you remember from last week's episode, this was the library that allows me to control that LCD screen. But everything else is going to be the same. So I'm defining, this is 12, defining my OLED. I'm starting my I2C bus, I am starting the OLED screen, then I'm initializing my LCD screen, and I'm initializing the backlight.
Okay.
If I left that backlight thing off, it actually doesn't turn the backlight on.
And we would just, I mean, we could maybe still read it,
You could still see it, but I mean, it wouldn't be lit up. Now, I've got two functions here, LCD test and OLED test. And if you look down at the loop, that's the only thing it's going to do. It's just going to keep running those two functions over and over again.
Okay.
Now, on the OLED, and on the LCD, this is the exact same example we had from last week. So it's going to write 4 lines, line 1, line 2, line 3, line 4, and I'm setting here, I'm setting here where that's going to be located. This was located on line 0, this is located on line 1, that's located on line 2, and this one's located on line 3.
Right.
Okay. Now in the OLED, same example. Hello world, goodbye cranky hippo. If I've done this right, if this is wired up properly, then both of these screens should turn on, and both of them should be addressable.
Okay.
So let's go ahead and upload this.
The moment of truth.
Okay, let's go into the right port. And give it a second, it's got to compile. It's compiling, now it's uploading. And this is going to reset really quickly. And boom, there we go. So now my OLED says it's doing the blinky thing, hello world and goodbye cranky hippo.
Right.
And my LCDs, line 1, line 2,
so cool.
line 3, and line 4. So that's one Arduino that's controlling both of those displays.
That is really fascinating that you're able to do that.
And the cool thing about this is now I can think of, okay, well, you know what? If I'm running out of space, I don't have to cram everything on one screen. I could actually have an auxiliary screen. Like this could be showing all my main memory, and maybe this one's showing temperatures or something that should always be up.
Yeah, okay. That makes sense.
Here's the fun thing though. Let's do another example really quickly. We're gonna be pulling the real-time clock in. So now we're gonna be using 3 I2C devices at the same time. And now you're going to start to see the limitations of using this approach.
Okay.
So here's the last example we're going to do for the episode. All this is doing is it's the exact same thing. We did real-time clock examples for both the OLED and for the LCD. Right. Now I'm going to use it here. So let's go ahead and upload this. This is 12, like so. Okay, so now once it's uploaded, if you go over here, now you can see that they're displaying different things. This one is displaying the time from the RTC, and this one is continuing to blink.
The hello and goodbye Cranky Hippo.
However, take a look at the clock. What do you see with the clock? Specifically, look at the seconds.
They look. Wait, did it just jump?
Why is it doing
Why is
that,
it jumping? Yeah, now it's at 38. Yeah, it's skipping digits.
Yeah. What do you think that might be?
Probably because of the lag time. So it's like, well, I was gonna say it's only doing even numbers, but now it's doing odd numbers. So it's because it's got powering the 3 devices and sending data over.
Kara, bring the lights back up and then go over to my screen. This is why. This is okay. It's cool that I can run multiple devices, but if you look at the code here, what's happening is, remember, this loop is going to go and do the instructions over and over again. So the first one it's going to run is the OLED function. If I look at the OLED function, this is normal. Yeah, set the text, hello world, goodbye Cranky Hippo, but then delay.
Delay 1000.
Delay 1000. Delay 1 second. Then clear the screen and delay another second.
So it's running that, and that's delaying the next command, which is LCD time?
Precisely. So LCD time runs perfectly, but every time I get to the OLED function, it's at least 2 seconds, because I'm delaying 2 seconds.
Okay, so how can you write around that?
Well, okay, see, this is where you have to start getting creative, because you can't just put delays in order to make things match up. If I'm using multiple I2C devices and I want things to be happening on both screens at the same time, I have to let the loop continue. I cannot use delay, because delay, it only does one instruction at a time. Delay means all of the chain of instructions stop until the delay finishes.
Okay, that makes sense. So how do you get around the delay then?
So what I would do is, rather than using delay, I would run an internal counter, and I will say, okay, keep running, but when this counter equals a certain number, then do the next thing. So it's gonna. So rather than saying wait 2 seconds, it's gonna say, okay, well, what's the time? 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 And then, oh, it's the time. Run it.
And then run. Okay.
So that keeps the system from halting, but it is a pain, because now it means I have to think in my head. I have to measure out exactly how much time I actually need to run. This is where the RTC actually comes in handy, because rather than waiting for what I think is going to be a second, I could say, just do this every second.
Okay, that makes sense. I would have not thought that. I thought it was just because we had everything hooked into each other.
No. Kara knew it.
Oh, she's so smart.
Yeah. And actually, since I've got an RTC in this already, what I would probably be doing is since I want to make this blink every second, rather than saying delay a second, I would just say, if the second equals even, show it. If the second equals odd, clear it.
Okay.
And it would just go back and forth, back and forth, back and forth.
Neat.
But this is a good place to stop, because it shows you that as you start programming more and more complicated things, and you start hooking up more pieces of hardware, you have to be aware of that. You've got a lot of interactions
down the chain. Yeah.
Down the chain. Yeah. If I want to delay this screen, well, I can't just halt the system, because the other parts of my project need that processor.
So if you're trying to figure out why your Arduino wasn't watering at the same time, that would be why. Okay.
And okay, one more thing, and again, from experience, it sounds really clever to use the RTC to trigger events, but if there happens to be lag in your software at all, what might actually happen is it jumps over. Like if I'm saying run this every even second, well, what happens if there's just enough lag in the system so that it only hits the RTC every time it's odd?
So it would never turn on.
It would never turn on. So just know that, okay? Just
keep that in mind.
Keep that in mind.
That is fascinating, though. Cool.
Now, Brian, what we're going to be doing next time we have this is we got to start showing them this little bad boy. Remember, we've got our little
your little cartridge with buttons.
And by the way, notice the plastic.
Yes, it still has the plastic.
So good.
You could take the plastic off.
No.
Don't take the plastic.
No, it feels good. Yeah. No, so we're actually I'm gonna get all of this into here, and we're gonna start looking at the Aquabase, the advanced Aquabase / the advanced Arduino / the advanced hydroponics lab.
Right.
We want to be able to build everything off of something this size, and we should be able to, because the logic, once I've used an Arduino Nano, once I've got the RTC in here, I should be able to just pull this and plug it to any system that has power and then connections to relays for the lights and the water. right? Everything else should be self-contained. So we're going to be getting into that the next time. Then we're going to take a break because we need to do the cosplay episodes of Know How. We've got Patrick coming on. And
yeah, that's why he's still on the big board right there.
Exactly.
He's going to be making his presence back on the show.
Oh, and by the way, we should probably mention, we've got a special thing planned for you. You may know that Nate has joined the TWIT team. We're going to be
prefer Nate OG.
Nate OG has joined the TWIT team. We're going to be bringing him into into Know How. He's going to be showing off a little bit of his passion to our Arquitas.
Yeah, that's right. We wanted to have him on the show, do some of the projects that he's passionate about. I think we're going to have a good time, though.
I think so. But that's it for this episode. Now, if you want any of the information that we brought up, and we do have copious notes, we have all the code. So again, you don't have to copy it down from the screen.
No, you do.
You copy it down from the screen. Yeah. Like with tracing paper and everything.
Actually, listen to the audio version of the show and try and do all the code.
Actually, maybe I should do that. Display.set, uppercase text, uppercase size.
I just read out the whole thing. Yeah. That sounds like an efficient use of our time.
Better is to just go to our show notes. And Brian, where do they find those?
They can find those at twit.tv/KH. And like Padre said, you'll find links to all the products that we've used on the show so you can buy them yourself and follow along, but also download the code. And while you're there, be sure to subscribe or download the episode because these are multi-part episodes and you're not going to want to miss any.
Not at all. And as always, you need to join us on the socials, specifically in Google+. Just go to Google+, look for Know How, ask to join the group. Very short approval process to keep out all the spam accounts. But once you're in, we have almost 11,000 Kitas. That's our know-it-alls, people who can help you answer questions, or maybe you're at that part of your maker DIY journey where you can start playing the guru, you can start playing the expert. If we want this hobby to grow into something more, we have to help each other. That's what it's all about. So please join us, Google+, and look for Know How.
That's right. But if you want to find out what we're doing when we're not on the set working on our projects, or maybe what's coming up in a future episode, you're going to want to follow us on Twitter. I am at cranky_hippo.
And you can find me at twitter.com/PadreSJ. And normally this is the time when we talk to Steve, Billy Joe,
Alex.
I don't, Alexa.
Oh,
sorry. Oh, I should. Sorry.
Now the editor
is
going to bleep
that out. Sorry about that. Sorry about that. Yeah.
Fun, Brian.
I'm just going to bleep it so it sounds like you guys are cussing.
Today, we have the rare of working with someone who was with Brian and I out in the field, Kara Cole. Kara, do you want to tell the folks what you do?
I'm an engineer most of the time. I produce screensavers on Saturdays, and I TD occasionally. You know, when you guys are desperate for a good TD.
Yeah, and actually Kara is head of the Department of Awesome, I've heard.
Oh, I thought you were going to say the head of the Department of Ball Busting, getting us to actually do work.
Yeah, awesome. That's the awesome part.
Both, yes.
Both.
Hey, Kara, where do they find you on Twitter?
Oh, at Kara080.
There you go. Follow her, and she, actually, how many followers do you have now?
I think like 430.
Hey, hey, she had like 12 when she started.
Yeah, no, I had like, literally like 12.
So, yeah, throw her some.
That was about a year and a half ago. So.
Yeah,
not bad.
Yeah.
Getting there.
Until next time, I am Father Robert Balliser.
I'm Brian Burnett.
And now that you know how,
go Arduino it. Can you use Arduino as a verb? Sure, why not?